Okay, welcome to our 6th week. We're in October. The weather's cooling. Yeah, it's this is the best time to live in the desert. All right. So today we're going to move into another area as far as databases and querying. I do want to thank you all. There were some interesting issues with the assignment and the quiz, so I am going to review that before I go into joins. So before I hit joins, I'd like to offer a review of last week's assignment and quiz. Let me back up here. So the assignment, and you all can see my screen, correct? All right. So just to open up the document here, the first question was to convert today's date to this written out, basically I'm asking you to write out the verbiage for the date, and you want to use the cis date. So let me pull over the query. Oops, put that up. Hold on. All right. Well, anyway, I have several queries here, so let me. All right, so for the first one, it was a simple conversion. You can do it several ways, but probably the best way is just to use a char sys date and this particular formatting here. And we're asked to showcase today's date. So let me do it this way. I have all the queries written out, so if I can get this to cooperate. Come on. You have to get right on the right one. There we go. So the first one was run this query here. And today is, and you could add the in there to make it be more of a sentence. Today is the 6th of October, and you can even eliminate the spaces, but that was the gist of what, oops, that's not going to work there. We have to use a concat in there. Well, anyway, you get the gist. So primarily, it was looking to spell out 6th of October, etc. So I accepted any of the formats. So that was that particular question. The second was, and please remember there are certain tables associated with the description, like this one, global fast food employees, but that's the F staffs table. So list ID name and salary for all global fast food employees. And that was I had all the queries here. I may not have them all, but this one, we had a few people. It's the here. Let's just walk through this together. So the challenge was last name, ID name and salary for all global fast food employees, and display salary with the $sign. Must have deleted that. Anyway, that is the F staffs table. So let me just walk through this right quick. And some of the queries here and some of them not here. Really not organized. So it says select and make sure, since we know this is the F staffs table, we know the columns are ID, last name, and salary. So select ID, last name, and then we're going to do the two. Well, let me ask you all, what's the best way to format our salary to match the requirements? So display salary with the $sign and 2 decimal places. What would be our formatting? Who's going to chime in to, so you can either use the chat or unmute. What's the rest of this query here? You know, it's going to be from FSTAPS, right? So this is your chance to participate. What type of conversion are we going to use for this? Anyone? You're all going to be silent, huh? Can you all still hear me? Am I speaking to myself? I just want to make sure we go through this, these queries. Someone's volunteering to char, question mark. That's not really confident, but we'll say to char. What, and then what? The salary field, right? And then what? And now what? Char. So we have to identify the format. So something like this. 9, I see a couple of responses. And what about 2? Does that look right? Who agrees with that? Oh, someone says the double 0. Who is that? Valerie? Oh, now she says the 9. All right. So we close that parentheses, select ID, last name, and char salary from FSTAPS. Is that all we need for this then? Is there a consensus? Let's run it and see what happens. There you go. 3 employees, $12.90-19, and $6.75, and this is probably an hourly wage or rate. So there you go. That's number 2. All right. And number 3, create a query that will format the DJs on demand. This one, there was a few issues. Remember, you do set the range of the output. So if you don't have enough numeric representation, that's when you get the number sign. And that's not a good thing if you're looking for the format of the output. So this one, we're going to use our good old DJs table. And that is, we all remember what table is that we're using for this? Oh. Very clear that we'll format the DJs on demand. D packages, low range, high range. Which table are we using for that? Anyone? Yeah, I have the wrong one saved here. Oh, I must have saved these at home. So what table? So select, keep this going. Is that D events, or D job packages, or D packages? Oops.
Wait, one.
Yep, D packages, because we have the code and a low and high range in that query. So select code. And I just wanted to expand that. And this is a good way to see what your column names are. Code. And now we want to format low range, high range costs in the format of that $2500 with the 2 digits. So once again, our 2 char and our fields here. So we have low range, right? That's our column name and our format in the parentheses. And we're going to assuming that, well, sometimes you do have to guess high. So, and this is where you might have problems. I'm going to go ahead and guess really high. It may not be that, but you can actually add parameters to eliminate zeros and other things like that. But I'm going to do a basic one. So I'm just going to call this one low, as use an alias as low range. Right? Something's wrong with this. What's wrong with low range? Does that look right? Doesn't seem right to me. What am I missing in here? All right. Well, we'll continue and see what happens. So that's the first, that's the low range. Then we need to add the high range. Right. Y'all will let me know if this doesn't look right, right? Everyone's letting me type away. Oh, I don't know if I need it to be that large. We'll see what happens. As high range. D packages, correct? All right. So if we run that, and you see with this formatting, as long as we have enough digits, we won't get any crazy output like the number sign. So that's what we're looking for that one. That's 3. And then we get into the null functions. I think everyone did pretty good with the null functions. So I'm not, as a matter of fact, most of the rest of these, I think the biggest problems were those first 2 for some reason in our little assignment. Does anyone have a question about some of the others using NVL and NVL2 in case? Yeah, surprisingly, not too many people missed 5, 6, or 7. So thank you all for your hard work. So that was the assignment. Did pretty good. The quiz, however, was kind of all over the place. So let me just review that, especially the first one. So remember, you really have to pay attention to the details here. Using the employees table, construct a query with the last name and the yearly. It's even bolded. So what is the yearly salary based on what we have in that table? The yearly salary is a salary that's in the table times 12. That's one thing that many people missed. Well, I do have the other queries in here, but yeah, if you want to see the other queries, just let me know. Let's see. Oh, I just did the long range. So this one would be, this one, there was a few issues. It's just a formatting, but it's a little tricky. So select and last name, right? And the yearly salary, so it's a different column. So to char, that one is used quite a bit. And salary, but it's not just salary, it's salary times 12, because what's listed in the table is monthly salary. And then our format, this one was kind of tricky as well, because King makes about 300,000 a year, so we want to make sure we allot enough digits. So yes. And there was a tricky part. I accepted it both ways, but it had these square brackets around. So now we're going to need to use a concatenation here. So in my mind, just our little square bracket and concat that with the salary, and then concat the salary. Oops. 2 pipes, remember, with the closing square bracket and our single quotes as normal. And we're going to alias that as yearly salary. I think most of you did this correctly. Yearly or annual salary. Okay. From employees. Right. And so if we run that, we get an output that looks like this. So King was 288,000 a year, and all of the employees, all within the square brackets. So that was the query that I was looking for this first one. And that was 2 points. And another one did give some issue, I think number 4. Now, so I do recommend, because you can always have your developer open, whenever I give you a query, if you have questions about it, just highlight it and run it. So the result, the hire date values must be displayed in this format, 25th of July, 2002. So you knew it's going to be one of these, and this is lowercase, so that tells you. And now, so let's see which one is it. Selection number 2. So what I'm recommending, just copy it into the developer and see what the results are. If it produces results. And so we want that format. But it's, it's going to be the date that's in the employees table, obviously. So if we ran this one, oops. Let's see what we get. That one actually gives you an error because of the. So this is what I'm saying. This is a good way to check. And like this one, your developer is definitely your friend. You can truly check to see, and it is okay. I mean, that's what I want you to do to ensure that these answers are applicable. And there you go, 17th of June. No, right, 25th of July, 2002, 17th of June. So the correct answer was C, or the third one. So a few people that did not get that one right. And yes, it's tricky because the only difference between A and C is that this is uppercase and this is lowercase, this is lowercase here, where this would be all uppercase, or just for the dumb TH. So that's being very picky, but that's what happened there. And then I think the other ones were good. Yeah, those two were probably the most problematic. So, but overall, I think you all did pretty good on the assignment. I just I wanted to review that right quick. So if you have any questions about that, please chime in. Oops. Yeah, let's see. All right, thanks, Trevor. Thanks for the chat. This is coming in. So let's get started on our lecture, because we get to learn about joins today. And a very, very useful tool in the realms of SQL. The ability to really expand how you connect tables. So our first topic in this module is cross and natural joins. Our objectives: construct and execute a natural join using the ANSI 99 SQL syntax, and you'll see the difference. Create a cross join using that same syntax. Explain the importance of having a standard, and that's between ANSI and Oracle proprietary. And you'll see the difference. And it's generally, since we're Oracle Academy, but ANSI 99 on that, for those purposes, is accepted across the board. Describe a business need for combining information from multiple data sources. And this is probably one of the key reasons to learn joins. But let's expand on that a little bit. Up to now, your SQL experience has been limited to querying a single table. Yes, we're going to go beyond that. This would not be a problem if all data were stored in a single table, which, by the way, it used to be that most databases were one huge table with millions of columns. Okay, not millions, thousands of columns and millions of records. But the whole idea of relational database came about. Since we're creating this connectivity between your tables, this is a good way to understand why that occurs. So essentially, this is saying data modeling came about and basically created the relational database design. And yes, SQL provides join conditions essentially to allow you to run queries. Oh, okay, Nicole is joining, so then marker is present across multiple tables, 2 or more. Oops. All right, so the join commands, or join itself, there are 2 sets of commands. Essentially, the syntax that makes the connection between tables. There's the Oracle proprietary, and then there's the ANSI standard. And we are going to learn both methods. Oracle, just to let you know, since Oracle acquired MySQL and some other database structures, it was advantageous for them to create their own proprietary, and it's been around. It actually, well, it's newer than the ANSI standard, and because it's simpler, maybe a little bit easier, but yeah. So we're going to primarily focus on the ANSI 99 right now. We're going to cover the proprietary joins, which is actually a little bit easier, but It's probably makes more sense, or I think it makes more sense to learn the ANSI 99 first. All right, so a little bit of a review, just to of course, we've gone well beyond just understanding what SQL is, but this language, the scripting language, was created because of this whole idea of the relational database management system, tables that are entities that are connected, primary key, foreign key, all of that came about. And I actually remember when this whole idea of RDMS, I was actually in my college days back in the 70s and 80s. And it did become the industry standard around the mid 80s. And they adopted the ANSI, basically the way that we're. So now your journey back to history, and there have been several, versions since well, not several. Particularly, there's only been 3 versions, ending in the ANSI 99. That ANSI 99 is still applicable today. Back during Y2K, they thought that if we decided to evolve that particular standard, it may have changed up to the turn of the century. So the decision was to just keep the 99, which has persisted. All right, so that's kind of a little historic journey as to how the standards were established. So let's type in the chat. We're going to learn how to confuse non-local DB devs. So what's the gist of your question, Trevor? How to confuse non-Oracle DB devs with? Can you ask that again, Trevor? Non-Oracle. All right, now I suppose if this is around, just playing around because the syntax with yeah, and we'll get there. It's very confusing, but yes, we will talk about left and right joins and how you can differentiate between which is which and why. And this is always kind of a challenge, but yes, we will get there. All right. So natural joins. An SQL join or SQL join clause combines basically fields from two or more tables in your relational database. I 2 or more. So a natural join is a way to combine rows from these tables based on a common column, which is usually, but not always, the same name. But it's always a compatible, meaning that they're compatible data types. So a natural join automatically identifies and uses these common columns to establish the join condition. So if you look at the employees table, and you can recognize that it has a job ID column, right? Which references the job ID column in the jobs table. And yes, they're named the same, just so that you know that one is referencing the other. So you can join on those 2 tables. So take a look at this syntax. This is the ANSI 99 syntax for a join. So select first name, last name, job ID, job title. So you know that job ID and job title or job title comes from the jobs table. All of the rest you can reference in the employees table. So employees, natural join jobs. So you're joining the employees table with the jobs table, and then you can add a where clause where basically we're filtering it to one department. Department is greater than 80. And you can add department ID if that seems confusing, but we know that Getz, Higgins, King, Kokar, and Dahan are all in a department that's greater than 80. I think they're 80 and 90 or whatever. And so this is their job, and we're pulling the job title from the jobs table. That's the key here. So a good way to remember this is that basically instead of 2 tables, we're combining them for querying purposes into one big large table. And because our common column across these tables is job ID, you don't have to really do anything else. It will naturally join the tables on that column, job ID. Does that make sense to everyone? That's a key, and that's how a natural join works, and it's really, really useful. All right. So, and this is essentially an example how we can join a table without explicitly specifying a specific column, because the system will assume that you want to basically make those employees, as far as their job IDs, the same. All right. And here's another example. Let's take a look at this. Department name city from department's natural join location. So we just want to pull out the department and see what city it's in. So we get the departments from the departments, get the department from the departments table, and the location or city, excuse me, from the locations table. And we don't even need to signify what the common or the common column, which is location ID. The system will assume that that's how you're going to join it. If you think about it, just at a high level, that would make sense. Okay. So this is a natural join. There's a column in each of the tables that will create the natural join, because usually, well, in this case, for ANSI, the columns have to be the same, named the same. Diana, go ahead.
Yeah, so I was wondering, will natural join not work if two tables don't have the same column with the exact same column name?
Yes, a natural join will not work. You have to do something else, and we're going to learn that to make sure you have a join. So a natural join only works if the column are named exactly the same.
Okay, thanks.
Yeah. Good question. All right, there's something called a cross join. I've not used much, maybe once in my DBA career. Cross join will technically join each row in one table to every row. So it's basically, well, like a full join in essence. But it's like a cross tab, sort of. But the result set represents all possible row combinations from the two tables. So this could produce a very large result. So you do have to be very careful with the ANSI standard on cross joins, especially if you have millions of records. You could bog down the whole system. So, for example, if you cross join a table with 20 rows with a table with 100 rows, you'll get 2,000 row result. Cross joins are normally used to test the performance, and for only that reason, because it combines all the rows with one table with all the rows with the other table. So, for example, if you did a cross join on the employees and department table, the employees table has 20 rows, the department table has 8 rows, you would get 160 rows. And it's, as I stated, it's generally only used for performance. I think I've run a cross join in production or in a production environment probably just once at a university. And I think I remember a return even back then, and that's probably 15 years ago. Yeah, 15 years ago. Yeah, it returned like, 10 million rows or something like that. But anyway, it's only used for performance. All right. So those are two basic joins under the ANSI standard. Natural join, remember, the columns have to be named the same. So our terminology for this very short topic is cross join and natural join. And let me check the chat. Anything new in the chat? Haley's table. Oh, well, Trevor, you're jumping ahead, so we'll get to that. Generally, if you're going to run a natural join, there's no need to alias the tables unless you have a reason to run a self join. But anyway, we will get to that. All right. And then NC 99, and then even though we're going to study proprietary later, remember that's the second standard that we will learn. Okay, our next topic is join clauses. So now we're going to get into the nitty-gritty of joins. Construct and execute a join with the 99 standard or ANSI standard. with the using clause, construct an executed join with the on clause, and construct an executed join, that will join 3 tables. Ooh, that sounds exciting, right? All right, so adding more columns to your database vocabulary allows you to design basically queries that return. Well, you've been doing this all along. I mean, essentially, you're focused on designing the query to produce a desired result. So the purpose of a join is to bind data together across multiple tables without repeating all data in every table or repeating the selection of data in every table. So why ask for more data than needed? So that's the whole idea. You want to get specific data, like you want to pull out the employee and their manager name or something like that to make sure you're running these queries to return exactly what you need. All right, so the first clause we're going to look at is the using clause. And these are part of joins. So in a natural join, if the tables have columns, and this will answer to a certain degree Diana's question, if the tables have columns with the same names but different data types, the join causes an error. The join clause can be modified with the using clause to avoid this. The using clause specifies the columns that are used in the join. So as you can see, if you have a using clause, you determine which columns you can join, and they don't necessarily need to have the same name. So take a look at this example. So select first name, last name, department ID, department name from employees, join. And in this case, okay, here's the key here. If you're going to use the using clause, then it's usually not a natural join. So just remember that. A natural join is going to look for the columns of the same name, no matter what your other clauses are. So be very careful. Be very particular about how you construct like a join like this. So even though we have, and we'll get to different column names, but here we're signifying which we could run a natural join, and this is kind of the caveat. We can run a natural join for this particular query, but this is an example of the utilization of the using clause. So there's department ID, and basically we're looking at the employees and what department they work for. All right. So the columns referenced in the using clause do not have a qualifier, or basically they don't have a table at this point. We're going to get into the details of how you can change that. But for now, we're just signifying which column we're going to use to join the tables. And Trevor did mention something about aliases. We will get to that and how that is important. The using clause allows us to use the where. So basically, you can add the where with using. So if you look at this query, we're only looking for Shelley Higgins. So essentially, we run the same query we did before, and we add the where last name is equal to Higgins, and hence we get the one result. We know that Shelley is in the accounting department. Does that make sense to everyone so far? Hopefully I haven't lost anyone yet. All right, I'd love to see those thumbs up. All right. All right, we have another clause, which is another, so that was the using. We have another clause, which is important as well. It's the on clause. What if, and this is where we essentially can provide arithmetic or comparison operators and other things, and you'll see. So what if we need to, offer other conditions like non-equality in between and et cetera? We can use an on clause. So it does allow for greater variety of the join condition, and it also allows the where. So take a look at this. Select last name, job title from employees. And now this is kind of answering Trevor's question where we can use, and you can kind of you should be developing an intuition to basically see how this can, be clear as to what you're getting and how you're they're combining or joining, excuse me, the two tables. So we're using an alias for the table. The alias for employees is E, just a single letter. The alias for jobs is J. So essentially, we're telling the system that, and you could also use a natural join for this as well. But with the on clause, we're specifying the specific columns. And you see here, what if the column, we know that the columns are what we can use to join tables, but what if they don't have the same name? So then you can expand that particular association, you can see that, yeah. So on, and generally the way a relational database is designed, you will see that the naming convention will allow for a particular column that makes sense to join on. So I think I do say this here. So to go way back to Diana's question, the on clause is required when the common columns have different names. So that's how you can join those two columns when the common column, and you can't use a natural join when they have different names. All right. So here's the on clause with the where. So the same as before, but we're looking for last name like H. So Higgins, Arstein, and Arnold. So make sure that that makes sense to you with the on clause and the aliases. As your queries get a little bit more complicated, and you'll see this in a minute, especially when you're joining three tables, and we'll talk about things like self-joins later. All right. So sometimes, as I mentioned before, you may need to retrieve data from a table with none, yeah, duh. So we're going to move into more of a definition. Suppose we want to know the grade level for each employee's salary. The job grades table does not have a common column with the employees table, right? But using an on clause allows us to join the two tables. So take a look at this. This is what's in the jobs grades table. It has a grade level, a lowest salary, and highest salary. So how do we use that? And then I'll take a look at this query. So we're just wanting to join, essentially get information on all of our employees. So this query, as read, select last name, salary, grade level, lowest salary, highest salary from employees, join job grades, and on salary between lowest salary and highest salary. So you're only indicating that we're trying to join this on, we're joining on salary, right? But it's between the lowest. So we're trying to determine the grade level of the employees in case this looks confusing. So if they're between 1,000 and 2,009 or 2,999, then they're grade A, etc. And we can see all employees that are different grade levels, all the way up to King is probably the highest grade. And the grade levels, as you saw here, from A to F. All right. So this is just used to determine the grade levels of the employees. So, and there's non-equal conditions in your on, and you can tag on a where clause to that as well. All right, moving right ahead. So that's two tables. So what about three or more tables? Before I highlight this, I guess I have probably used joins the most when it comes to complicated queries. And yes, I probably join as many as, 25 tables for some particular purpose. Now, these were small tables, but it made sense to join them. So do you generally need to do that? No, but this was something that had to be done during that particular, well, anyway. But the key here is that you can join more than two tables. Both using and on can be used to join three or more tables. So what about this scenario? We want to report the employees, their department, and the city where the department is located. That's three different tables: employees, departments, and locations. And here's our query. Now, I do want you to pay attention. I did not structure this in a way that it would organize so you can see the join. So before I explain the query, there's a general rule. If you're going to join 3 tables, then you're going to have two joins, 2 join clauses. You're going to have 4 tables, and it's going to be 3 joins. So 1 minus the number of tables will be the number of joins. And so you see here, select last name, department name as department. So I'm just shortening the department name as department, right? City from employees, join departments using department ID, okay? Join locations using location ID, right? So location ID is common between departments. The department table and the location table. The department ID is common between the employees table and the departments table. So we get our report, last name, department, and the city where the department is. Does everyone see that? Does that make sense to everyone? This is my check-in. This can be a little confusing, but please remember that general rule that I stated before about the number of joins and the number of tables and the number of joins. Okay, another short lesson. And what we learned here, the on clause, the using clause, and not listed here is just multiple tables, joining more than 2 tables. Pretty straightforward. Joins are very powerful, very useful. It will definitely, I think it's probably one of the most useful clauses in SQL from any level. I've used joins. I've even used joins recently well, anyway, it's very useful. All right, so now we're going to move into a little bit more complication or just, something else you can do with joins. There's inner versus outer joins, and I guarantee you these will be somewhat difficult to grasp in the beginning. This is another one of those scenarios where you really need to run those practice, and so you can see and visualize. And generally, I'll draw the Venn diagram and the 2 tables and how they intersect and what's the but I think I do. I don't know if I took that out but anyway, let's continue. So our objectives: compare and contrast the inner outer, construct a left outer, construct a right outer, and then take a look at a full outer, which is rarely used. And that's basically just a full join, bringing back all the records from both tables. All right. So our purpose up to now, joins return data that match the join condition. Sometimes we want to retrieve both the data that meets the join condition and the data that does not meet that condition. So, and you'll see, and it may not make sense now. Wait, we're gonna return both. Well, it really depends on the table, and that's where the left and the right comes in. That's where you really have to wrap your head around which table is which table is the left, which table is the right. And I think Trevor was referring to that, but it can be a little confusing. All right, so the outer join in ANSI does allow for this functionality. The inner join is a join of two or more tables that returns only matched rows. So that's the inner join. It's only gonna, if you think of a Venn diagram where they intersect, hence inner, is basically what's going to be returned. So if you have the employee ID on one table, it only return data if the employee ID matches on the second table. When a join returns the unmatched and matched rows, so the outer join is that it returns the matched and unmatched, depending on if it's the left or the right. And before I get there, think of left and right as 1 and 2. This is my general rule. Left is usually the 1 table or first table in your select statement. 2 is usually the right, or right is usually the second table or table number 2. It's really that straightforward. Left, right, 1, 2. I know that there's been other debates about what a left outer and right outer means, but hopefully when I get there, it'll make a little bit more sense. And once again, please run the practice queries to see for yourself what is represented in those result tables, which is where SQL Developer is very, very, very important. So yes, the terms are associated with the order of the table in the from clause. Table 1, the first table is left, the second table is right. So left and right outer joins, and notice, I think that's the left hand, right? Right here. Anyway, take a look at this query. Select E, that's just an alias, no panicking. E last name, D dot department ID, D dot department name, no employees. And the first table, so remember from taking a look at our from, the first table is employees table, the second table is the departments table. So our left table is employees. So a left outer join, think of it right away that we're going to return everything in the left table. So we're going to return all the employees, which we see. All right. So that's a left outer join. So it's going to return all the employees. That's what matches. And then it's going to return all of what's matched as far as department ID, and then the ones that aren't matched. So you see that everyone has a department except for Grant. And this is the perfect scenario for this is, let's check this to make sure everyone is been what am I trying to say? Everyone's been assigned or been a part of a department. Now, left outer join. So the left outer join is the left table, employees table. So that's the key. The outer says everything in that table. And that's why we get the results where it's everything, and then we get these nulls because Grant does not have an department. All right, does that make sense? Because that will frame your understanding of the whole left and outer. And it's really not that difficult. And if you can grasp these simple tables, the more complex left and outer will make more sense, especially with this ANSI SQL. All right, so then the right outer join the same query, and yes, there would be a reason to run this. So in the same query, you notice the departments now, every single department is going to return, and then only it's going to, once again, the employees that don't, we don't have any employee assigned to the contracting department. Now, you notice that Grant is not here because we're not returning all of the employees, right? Only the ones that are all the departments. But so that's the key here to make sure you understand. If you look at the left outer, we have Grant, he has no department. You look at the right outer, we have contracting, we have no employee. Does that make sense? So understanding that situational reference about the outer join, that distills any kind of most of the confusion. And it would be essentially based on whatever you're looking for. If you're looking for departments without an employee or employees that aren't assigned to the departments, that either one of these queries would match your requests. All right, great. You're all catching on to this. We're pretty, it seems like, so I saw a lot of thumbs up, and that's a good thing. Now, full outer join, it can be useful, but it returns everything, all the information from both tables. Maybe you're an overachiever and you just want to check everything in one swoop, then you would run a full outer join. So it just basically all the employees, all the departments, and it shows any employments without a department, any department without an employee, and that's essentially what you see here with the null and the contracting. That's a full outer join. And sometimes it's easier to run a left or a right depending upon your scenario, but in a small data schema like this, yes, you probably want to run a full outer join. So those are outer joins. Outer joins are not that difficult. Inner joins, basically, it's an intersection. Outer joins is basically whichever table is indicated is a table that will return all of its records. Any questions about that? I think you all seem to be grasping that concept. If you are confused about that, I mean, I will suggest again, please run those practice queries. It'll make more sense as you see the results. All right, so here's a scenario. Construct a join to display a list of employees, their current job ID, and any previous jobs they may have held, and use the job history table. So we're all going to help to create this query. So we got two tables, right? I'm not going to show you the query yet. So we got we have the how am I going to do this? So we want to use the employees and the job history. So we want to list all the jobs that employee has had. So which table would be our outer table? The employees or the job history table? What do we all say? Let me delete all my queries. So we're going to select and you know what, last name. Yeah, let's do last name. Then the current job ID and previous jobs they may have. All right, job ID, is that the same as employee ID? No, that's different, right? So select job ID. Now we said last name first. Last name, job ID, and yeah, we may or may. Now here's an interesting. Now you may decide to use aliases after the fact to try and ensure that you know which column goes with which table. Oracle is set up so that even though the column doesn't exist in the table, but we know job ID is in, or let's just verify. So we have the job history table. It has job ID. We have the employees table. It has job ID. So, yep. Now, we're assuming that that's the same column. That's a common column. And yeah, that's a good assumption. So, select last name, job ID from employees, left table, right? And we're going to say join jobs. Now, what do you think? So what's going to be the result of this query? Will this query run? Or do we need? All right, let's just experiment here. What if we do a natural join here? So can we run this query?
I think it will be okay.
Yes. So we got, and we're not running a left or an outer, so it is bringing back, it should bring back just all 20 employees, right? So we don't get really a job history. And basically their current, we're going to assume that this is their current job ID. We know Keen is basically the president, so, and Kokar's the VP. But we want to know all of their all of whatever they've worked on, right? So what if we do we do, what type of join, a left outer or right outer? What do y'all think? Anyone want to volunteer? Go ahead, Diana.
Well, actually, I had another question. Since they both have, since employees and jobs both have job ID in common, like anytime you have a common column, can you just use natural join and then you can reference any of the columns you need? Like we could just pull job history and it would know that it's from the jobs table.
Yes and no, but we want we want specific criteria for this query. You're right. It will assume, since we're running a natural join, but we want all the jobs that each of the employees have had. So a natural join will only, that's basically an inner join. Does that answer your question?
I think so. I think I'm still getting a hang of the inner and outer, so yeah.
So if we want all the jobs based on the history table, which table, or if we want all the jobs all employees have had, which table would we want to return all the records?
The job history.
Yeah.
Oh, so we need to do another, join another table, like 3 tables?
Yeah, see, all that I did, okay, so let's do this. So we didn't even use the job um, uh, history table. We just brought back the employees and their jobs, their job titles, right? Does everyone see that? Yeah. So I actually I used this table. Job title, actually we didn't even bring back the title. And we just brought back the job ID, which is kind of a reference to the title. Let's change this a little bit, just so you can, before we actually do the query, if we bring back job title, then you actually see the title, all 20 employees and their title. So now King is the president, but it has a job ID that we know, but we want to know all the jobs they've had. So, and that will be the job history table. So if we want to indicate the titles, so that's 2. So yes, we probably want to do another join, right? You're going in the right direction. I'll even stick with well, can we stick with a natural join for 2 table or for 3 tables? Who wants to answer that question?
No.
Diana says no. We have job ID on employees, job ID on job history, job ID and jobs. Let's see. Well, we'd have to indicate another. Remember, the join itself. Yeah, I do want to state this. The join itself is always in between 2 tables only. So the first join is employees and jobs. The second join is jobs and job history. So we should be able to run a natural join from there as well. I would think. So will this query run, or would it give us some problems? Who says it will run? Diana, are you going to be the spokesperson for the class? She says it's going to run. She probably already tried it. So what happened there? Now we only have Taylor is the only one that came back with that 3-way join. Why? Who can tell me why? I kind of said it before. Let's look at the chat. Because the natural join is only going to, it'll look at those common, and this is where it becomes very tricky. It looks at the common column for each of these tables, table 1, 2, and 3, and it brings back basically the only record that's common across the whole. So that's actually not a good way to indicate, and this is a very maybe not such a good example, but it's a good way to see that that's probably not what you were expecting. So we see in the job history table, we have the job ID, we have a start and end date. So we can bring back the title, but how do we bring back all the jobs? What if we try, and I'm just experimenting here, I don't even know what my solution is. What if we try a right outer join for the job history table? So the right outer join will say that it's going to bring back all the history, but is it only going to bring back the history of Taylor? No. So this particular type of join you cannot do. Cannot do a right outer join with the natural join. Yeah. So what we need to do, since we know we don't have job title, you have to go back to job ID. In this case, so we're experimenting, and we're going to take out our jobs table and just use job ID with a right outer join for job history. Or there's ways around that, but how about this one? Is this going to run? Am I losing everyone? And it's like, oh, I don't know what he's doing. All right, let's see what happens. No, I'm missing a keyword. Oh, so what do we need? You all remember how the right outer join worked? Let's go way back. What do we need for that right outer join to be successful? Either using or an on. That's. Go ahead, Diana.
Did you have to designate which table the things you're selecting are coming from, like with the alias in front of it?
Yes. Oops. That was my solution. So yes, that's a good place to start. So let's use our alias E and JH on E job ID equals JH. All right. Let's see what happens there. No, still missing something. What are we missing?
Do you need the E and JH in front of the last name and job ID?
Well, definitely job ID, because it says there's an ambiguously defined column. Yeah, Oracle definitely doesn't like that. So because that's a common column and you're doing a natural join, and you're defining it on that column. And we know that that's the same, so you can either use E or JH there. But you see that what we have here, since we're using a right outer join, it's giving us all the employees that have multiple, they've been employed in different roles, although Abel, sales rep, but Davies is a clerk twice. Is this the right information? Well, we would need to know more what's happening here. So, all right, I'll try not to confuse you more. Take a look at the solution that I came up with. Yes, it does use last name, E job ID is job, D's job ID is old job, end date. So you need the end date from employees, left outer join, job history. I'm using a left outer join to bring back all. Now, which table is our left table? Employees. So all employees that have had more than one job. That was the whole requirement, or all of their previous jobs. Go ahead, Diana.
Sorry, another question. I just don't get why, like, how did it bring back the multiple job history, like the previous jobs, if you did a left outer join? Because wouldn't it just list like all the employees like once because they were just like all of them in the left table?
So good question. So all the employees are in the left table, but it's going to match that employee with a job that's in the right table. So whenever there's a job instance in the right table, because we're joining it on, see, we're joining it on employee ID, not job ID, right? So the employee, even though they're listed only once in the employees table, but they're listed twice in the job history table,
Oh, that makes sense.
right? So and all the ones that have now you can further clean this up by saying where old job is not null, and so then you know the king, etc. Oops. Does everyone see that? And then it will bring back truly a list of employees. So this is saying a list of employees, their current job, and any previous job they may have held. So the king, just they hired him as president, and that was it. Kokar was account manager, and then, or he was in accounting, and then he was the manager. Dahan was hired as the IT programmer. He's the VP. Oh, no, excuse me, I'm reading this wrong. The old job is that Kokar was a manager and then the VP, or actually he was an accountant and then a manager and then a VP. Actually, he had two movements. And Dahan, IT programmer, and then et cetera, et cetera. So that's what it's representing, old job, new job. This is their, this reads a little confusing. We could probably clean this up, and maybe I'll do that. But we can clean this up so it makes more sense. This was kind of an easy, this is the way Oracle signified, an easy way to read who's had, all the nulls have not had previous jobs. That's what it's saying. So you can kind of clean it up by referencing the nulls, in this case, using your null functions. But the left, yeah, the left, and this is kind of tricky because you're right, Diana, you probably want to do a right outer, but the left will bring back all the employees. We want to know all employees, and if they, yeah, see, it's really based on whatever your condition is, and yes, there's multiple ways to do this. So I want to re-illustrate that this isn't the only way to perform this task, and this may not be the cleanest way to present this. So, all right, let's move on. All right, so in this third topic, inner join, outer join, left outer join, right outer join, and full outer join, or full join. All right, the last topic, self-joins and hierarchical queries, which is hierarchical queries aren't, well, you'll see, they're not really joins, but it's a topic that Oracle Academy thinks is important. So you're going to construct a self-join, basically joining a table to itself. And there's actually the reason why the example that I'll show you is one that's probably the most used. Interpret the concept of a hierarchical query. create a tree structure. Now we're getting into the hierarchy, org charts and all that. Format hierarchical data, which you don't really use anymore because of all the ways that you can take data and represent it. So this hierarchical queries, I may substitute that for something. All of this is really not used anymore. To be frank, no one uses data to create org charts. They use that, well, they'll use a hierarchical query and pump it into something more visual, et cetera, et cetera. So just to let you know. All right, so in data modeling, we sometimes, basically it's necessary to join a table to itself. We show this by using a recursive figure. That would be the kind of the image representation of it. So once we have a real employee, well, we have a real employees table, a special kind of join, and this is called a self join. And basically you use this to access data in a certain way. So basically you turn one table into two tables by using a join. And this is where an alias makes sense. So if you take a look at this query, select worker dot last name. Worker is just an alias. As you see, we have employees worker, employees manager, just aliases, right? No big deal. So worker dot last name and then manager dot last name. So it's the same column, but you're looking at two different aspects of it. And basically you're putting together a result where you're indicating this particular employee works for this employee. So, and you're looking at the worker, the manager ID is equal to the manager dot employee ID. And that does take a little bit to wrap your head around because of we're dealing with one table. So employees is worker is employees, manager is employees. And basically within that table, you have an employee ID column and a manager ID column, which is the manager of that employee. So that's what we're signifying in this query. And when we run this, basically, and as you see, King has no manager, but Kokar has King as a manager, Don has King as a manager, and we could use this to indicate their last name. And I think I do run this. So this is what it looks like from our developer. Arnold works for Dihan, Faye works for Harstein, etc. Just using that same indication. And that's basically using a table, since we have that information all in one table to join itself. And this is probably the biggest usage. Because you have a personnel or employees table, you don't necessarily need to make a manager's table because a manager is still another employee unless they don't want to be. They want to be exempt from all employees, but usually it's not the case. Usually the structure of an employees table or personnel table looks more like this. This is a very good example. Does that make sense to everyone? The whole idea of a self-join and what we're looking at. Any questions about this worker.manager ID, manager.employee ID? Remember, manager ID and employee IDs are actual columns in an employees table. So just to verify, if you look at our employees table, we have an employee ID and we have a manager ID, right? All right. All right. So let's take a look at hierarchical queries. And remember these, and basically they are closely related to self-joins because you want to kind of depict pictorially the hierarchy or essentially build an org chart. And yes, you can do that with SQL. So we all know, imagine a family tree and you got grandma and grandpa and the offspring and then their offspring and the offspring. So So you can use hierarchical queries to retrieve data to create this relationship, like who works for who in the same scenario. So if we ran a query on the employees table, you see that this is what, the base structure is, job ID, manager ID, etc. So if we're able to pictorially represent an org chart of our employees table, it looks something like this. Now that's nice and clean, but we can use SQL to do this. We have to, there are keywords that you need to use with a hierarchical query. Start with connect by, prior, and level. Start with identifies which row to use as the root for the tree, basically the top, but root, yeah, it gets a little confusing. Yeah. Connect by prior explains how to do the inter-row joins. And we'll see this once I identify an example. So take a look at this query carefully. Select employee ID, last name, job ID, manager ID from employees where employees start with employee ID 100. He's the base, King is the president. He's holding up the tree. Connect by prior employee. So you're connecting that employee to the manager. So you see King has no manager and so on down the hierarchy or up the tree, whichever way you want to look at it. So the start with and connect by prior sets up that hierarchy. Okay. And if we wanted to do a walk to the top scenario, so we do the same reports to start with King, connect by prior, etc. And you see we have this nice little hierarchy. And yes, there's a way to select a level. You can use a level or what's known as a pseudo column to say who's the root and then how everything's connected. This can become a little confusing, but it's just a representation in many ways of the org chart. Now, there's ways to create this little picture here where you have offsets, with the underscore that we just use basically LPAD, some of the other functions. And yeah, I've run this probably once in my career. It's really hard to tell, I know in this representation, but even in your regular data. But, you can run this query and it would look sort of okay. But that start with and essentially connect by, yeah. So in Oracle, it talks about pruning branches. If someone is fired or terminated and quit, you can simply use the query to X them out. So basically we're saying Higgins is out. And so, a little scenario, if we essentially set a where clause not equal to Higgins, now Higgins is out, or we can actually kill a connection by essentially adding that last name not equal to Higgins. So basically now Higgins is not the boss of Getz and so on. So I'll state that hierarchical queries are okay. They can be a little confusing. You will need to run a couple. But as I said before, usually the representation is something more image oriented, not based on the query itself and the result. Especially if you have a lot of employees. I mean, you probably want to send that result to some programming languages outside of SQL to get your org chart. All right. So our terminology for today, the hierarchical queries, we connect by level and then self-join and start with all, relatively useful. And then that whole tree structure, the root or the top of the org chart, etc. Tree walking or tree pruning, branches, etc. All right. So we made it through joins and hierarchical queries. Let me go ahead and walk through our responsibilities for this week. We're in module 6, joins, cross join. I didn't cover equal join because it's not really something that's needed. Yeah, Oracle refers to it, but yeah, if you're interested in equa and want more about it, it's not going to be in the midterm or anything like that. And that does remind me, if you scroll down here a little ways, we do have a midterm coming up, essentially the last week of October. So as I said, you have to dress in your Halloween costume. That's going to be a requirement. Take a picture of yourself and then take the midterm. So the midterm is coming up. So unless you dress up in a Halloween costume, I won't grade it. So anyway, all right. So back to our module 6. And yes, I will provide more information about what's in the midterm and how we run it with the lockdown browser and all that. So stand by. So I will post a lecture and recording here as usual. We have some pretty good videos in here on joins. Make sure some of them I didn't cover. The cross or Cartesian join, which you rarely see, left outer. Yeah, these are actually pretty good. He goes through them pretty well, my friend here. And so please, if you need some extra information about these joins, especially the outer joins and the inner joins, please take a look at our little videos here, our friend. And then the practice queries, I will suggest these highly. Joins can be very tricky, but once you can get a handle of what happens, and there's a few hierarchical queries in here too, if you really want to run those, but I would focus more on the joins. You do have to go through a hierarchical, but and then our practice, our try it, solve it practice. And yes, you guessed it, there's 4 of them with their solutions. As usual, very useful to get that practice in so you're ready for the assignment. Once again, I will say, please make sure you're running your assignments, building your queries, or at least copying and pasting your queries into the SQL developer and running them to make sure you're using the correct tables and producing a result. That's pretty important. I do check those closely. I usually will generate a list of the queries that I'm expecting, but once again, I do want to state that there's always several ways to do it. So I usually, if I have a question, I'll usually test your queries in the developer. And here's the hierarchical queries, practice queries. I did separate that from the joins. If you're interested, please go through those. And then on to the assignment. The assignment, try it, solve it. And once again, it's useful to download the document, and you do have 10 questions. 1 is an extra credit. Extra credit always gives you bonus points. I think 2 points. So it's always useful to go through those, do the extra credit. It doesn't count against you if you get it wrong, obviously, the whole purpose of extra credit. And that's the assignment. Yes, and you only have 1. And then the quiz, which will cover cross joins, natural join clauses, inner versus outer, and self joins and hierarchical. And that, folks, is that. Any questions or comments? So let me stop my share. Yes, Diana, go ahead.
Could you please explain like what the on like statement that comes after the join part is for one more time? I kind of got confused about that.
All right, so generally the on and the primary purpose of the on, like you had the question, what if the column names are different?
Mm-hmm.
So you would use the on in this case to indicate which columns you're joining on. That's the whole purpose of it. in this case, we could run a natural join because the column names are identical, but the on will signify explicitly what you're joining on. And there's a specific reason because you may have something like, and this happens all the time. You have an employees table. Let's say you have like employees and then an address table. But in the address table, you don't have employee ID, you have address ID. But that address ID is exactly the same information as the employee ID. You would have to use the on. Employee ID is equal to address ID.
Okay, so they have to be the same like data type also, even if the name is different.
That's correct. That is absolutely correct.
Okay. Okay, so one last question on that. If you were to like just select and do the wild card and return everything, that column would kind of be like the middle, or it would show like, well, I guess this depends on the kind of join you do.
Right.
You know, I'll just work on this a little bit this weekend, message you if
So
I
yeah, so generally, I'll give you a kind of a heads up. Generally, you're not necessarily running a lot of outer joins. Generally, you want the common items between the two tables to be in your result. So you're either running a natural join or truly an inner join with your on clause, on clause. For
Oh.
example, that employee and address, you want to map the employee to their address, right? So
Mhm.
that's where you would use just a join, and that's another syntax. A join in the ANSI is just join, or an inner join is just join. An outer join is either left outer, right outer, or full outer. But you can also put inner join. The system will recognize that as well. All right. Any other questions? Now, joins are very interesting, very powerful, very useful. So please practice on those. And if you have any questions, please send me a message, Canvas message. But hang in there. We're getting through all this, right? We're all doing pretty good. Great. Okay. So that's a lot. So please don't wait until the last minute to do those assignments. And yes, I will answer any questions as they arise. Thank you for your attention again. I will see you all in another week, right?
Thank you. See you next week.
All right. Take care.